Thanks, Frederick. Could you please share my screen? So while Frederick hopefully finds that, thank you. So we're here with Greg. Yeah, we're going to talk about automating drawings in Tekla Structures using Grasshopper. Or actually, I'm going to let Greg talk about that because it's all thanks to his great work that we're able to do this at all. And you've seen in previous presentations today already that we have had the Grasshopper Live link for the modeling side already for many years, and it's quite well established with a lot of users. But it always lacked anything for the drawing side. And that is something that Greg now has fixed. And amazingly, in his spare time, he actually has developed a complete set of components for automating the drawing side in Tekla Structures from Grasshopper. And you can now find both these links on Tekla Warehouse. Just make sure that when you go and look for the drawing link that you pick it from Greg's collection, because then you will get the most up-to-date version. He's released it as an open source project, so there are some older versions available as well, but this is the one to go for. And then I'm just going to introduce the bridge that we're going to be using today. So it's this one here. It's based on a real project in Brazil, which has been then laser scanned and remodeled here at Trimble using the bridge creator tool. So I'm going to have it on screen here just for a moment so you can see it. You might be familiar with this one, but the idea here is that you pick some kind of alignment, which we can see here in the model. It can come from an XML or land XML file, for example. Then you pick your stations, where do you want the bridge to start and end, the location of piers, and so on. And then you have your parametric sections that you create, or the profiles, which can then be used to generate the bridge deck. And we can also generate the abutments in the same way from Bridge Creator, and we can place components like the piers or the pillars here, all from Bridge Creator. And I guess the point I want to make with this is that when we then start producing drawings in Grasshopper, it doesn't matter where the bridge was coming from. So it could be from Bridge Creator, it could be manual modeled, it could be an IFC file that got converted in Tekla. So what Greg is doing then, he will pick up the geometry from Tekla, not from another Grasshopper definition, and use the Tekla model as the starting point. But of course, we can still do this using Grasshopper as well. So I'm just going to show on screen here a Grasshopper definition, which will produce a similar bridge. And this script or this definition will be shared then in the material. So Greg has compiled some material for you later, and we'll include this file there. So I'm just gonna show you the different parts in this file and how they actually map to what we have in Bridge Creator. So if I go back once more, well, we can see that in Grasshopper, we also start with the road alignment. We can read it in from Rhino, or from a CAD file, or from Tekla Structures directly. Then we define our stations or the chainages, similar to Bridge Creator. And we also have the profiles or the sections, the geometry of the sections that we can here create using Grasshopper. Again, similar to Bridge Creator. So you can do everything you can do with Bridge Creator in Grasshopper, but here you have like the full control of all the coding behind as well, if you have a more complicated bridge. And finally, if I just let this recompute, we can see how it will generate a similar bridge here in Tekla to the one that we had with Bridge Creator. And like I said, any one of these can be used as a starting point for Greg's drawing plugin then. So with that short introduction, I'm gonna hand it over to Greg, and he can show you what he can do with these bridges.
Thank you, Sebastian, for this introduction, and also I would like to thanks for inviting me here, especially for Gabriel, because it was his idea to bring that knowledge to the community. And just a question to moderators: can you now turn off the Sebastian screen? Because let's just start with only the Thank you. Okay, so The drawings in Tekla structures are quite complicated because they are steered mainly by the model. So whenever we will try to take that control by the grasshopper, we will have to find our way how to do it. And that's what I want to present today. So I will start with the general overview. What is the Grasshopper drawing link? And then I want to focus on some smaller steps which are needed to get the final result. So as you can see, views, dimensions, level marks, stuff like that. And I want to do it because there are some tricks, some nuances about all of those things, which I believe you should be aware of. So let's start with the first, the drawing link itself. And now I will just write open the video, it is the same structure as presented by Sebastian, and here is the script which will be shared with you at the end. And the script is responsible for, at first, getting knowledge about how big that GA view should be, what should be there placed. And then with the specific attributes, the view is created and some dimensions are placed. But of course, one view is not enough, so there's the logic for the next views and for the some sections. And now we have some scaffolding, some first version of the drawing, which was steered by the Grasshopper Tekla drawing link. And as you can see, all of those things, they should be separated logically by some business logic. Like here, there was just placing the level marks for the bottom of the pies. And of course, every time you will want to move those views according to your need to place those. And typically, you are doing the positioning at the end when you know exactly how big the view area is. Of course, you can place the dimension lines with the drawing link, and it is something which is very used, especially in the GA drawings, because for those, when you want to dimension the drawing parts, it's there is almost no native tool to do that. So if you want to steer that logic into by yourself, then it is possible with the drawing link. And as Sebastian said, the drawing link itself is the MIT project. This is the open source project. So you can download it, you can use it commercially for the students project, whatever use case you have. You can also wrap it, change the name, and sell it. That's not something what is prohibited. And there's always the question why I am doing that. And the main reason is because I strongly believe that you should take the control over the drawings inside of the Tekla. And the Tekla has a very extensive open API, but that's the C Sharp, that's the software development, which can be a little hard. So with the Grasshopper, it is possible to do it. So here we see the GitHub page, and this is the main source of the source code. And also here you can raise some issue if you don't know how to do it, or you have some questions, or maybe you want to raise the bug. So this is the place where you should start to asking your questions, because then the community will be able to respond to that. But as Sebastian pointed, the Grasshopper Tekla drawing link is also available in the warehouse. So if you want to download the TSAP file with all of those DLLs, then just go to the warehouse and you will be able to download the drawing link. And okay, you have downloaded it and extracted it. And the question is what you should do with those, because this is also very often asked. The LiveLink Sebastian work is coming with a very handy installer, which is taking all of those duties from your shoulders. But with the drawing link, you have to just extract those files into the typical Grasshopper libraries directory. And then, thanks to the magic of Sebastian installer, it will be loaded according to the opened Tekla version. So the problem is gone, and you can utilize both the LiveLink and the drawing link together. And just be aware the drawing link is not self-sustained. There you will very often have the need to use the live link, because whenever you want to create something on the drawing, you need to have the idea over the model side. So typically you will use both links to achieve your results. And in terms of the numbers, the drawing link is a combination of over 150 components. There's quite a lot of them, but let's try to just recap what is available to automate your workflow. And as you can see, the ribbon is split into some logical parts. At first, you are able to just pick something from the drawing area, some drawing objects, some lines, some points. Then you can create whole drawings from the scratch based on your knowledge and your needs. Or maybe you can go with a little more easy way. Maybe you just want to open the drawings associated with the model object, or just open some drawings from the drawing list. And then you are able to query or modify the typical properties, title 1, title 2, title 3, things like that. Then there are the views. And very often you will want to create the new view. But also you can just try to modify the existing views because maybe that's what you need from the drawing link. The parts area is about the translation between the drawing part and the model part. And it can be confusing, especially at the very beginning, but in the Tekla Open API, it is like that. There are two different kinds of the parts, the drawing and the model one. So you will just go back and forth to get the correct properties. And if we will go next, then you will find the attributes because in the drawing area there are multiple of different drawing primitives or drawing parts, rebars, weld marks, welds, bolts, stuff like that. And all of those they have this in the old era the UI with the properties, but now this is the side pane visible on the right side. So you can steer with the drawing link how all of those objects look like. Then we have the geometry. And the geometry is quite extensive one. And very often I am asked, okay, so why do I need the grasshopper for it? And then I am typically answering that, hey, with the grasshopper, you can utilize the power of Rhino geometry engine. So you're able to cast some shadows, to get the projections, to do a lot of stuff around the quite raw B-reps coming from the Tekla. You can adapt those B-reps according to your needs. In the miscellaneous tab, you will find all of those things which are brought by the community. So whenever you have some clever, bright idea, then just post it on the GitHub, and probably in the next release, it will land here in the miscellaneous because all of those things are the response of the need of the community. The UDAs are quite self-explanatory, but then we have the plugins. And with the Grasshopper Tekla drawing link, you can insert the drawing plugins. And there are a lot of different, very useful drawing plugins inside of the Tekla ecosystem, but they always suffer with one very particular feature that it's quite hard to place them, especially in a batch way. When you want to place them numerous, multiple of those, then every time you have to pick those objects, click and wait. And with the drawing link, you can automate, you can streamline that. Then the dimensions. And this is the big part because as you can see, based on the images, you can place the straight dimensions, but also the curved one, a radial one. And this is all what you will do. And I will touch it more robust in the next few slides. The annotations are there to place some symbols, some DWG symbols, or from the 2D drawing library, maybe some text, maybe some drawing primitives. It all because someone asked for those. The modification is for the modifying the drawing content, but I want to highlight the export. This is the final tab. So the export is to create the project deliverables. So all of those DWGs, all of those PDFs, all of those IFC files or 3D DWG, because there are some projects which still are using this quite old format, they can be exported from the Tekla with the drawing link. But okay, that was just quite raw essence from the drawing link. Now let's go to some sample. And I will start with the view creation because, as I said, this is something which is used quite the most. So there are different there are different kind of the views. So here we are in the bridge section, so we will work in the GA view, the model view. And whenever you want to place the model view or the part view, then just always start with some lightweight settings. Because very often when you will want to place the view in the GA, it will take quite a lot of time to insert because Tekla has to make all of those heavy mathematical computation, all of those hidden line algorithms, and it will take some time. So as you can see here, it took 10 seconds to just place that elevation. So when you're just trying with the drawing link, and you have some quite complex geometry with a lot of triangles there, then please use very small, very limited attributes. So no rebars, no part marks, no rebar marks, no welds, just parts, and with the most simplistic approach. Then you will be able to quite comfortable work with those drawings because whenever you will change something on the left side of your component, they will be recomputed. So if you don't want to face the sluggishness of that approach, then just use the lightweight settings at the beginning when you just try to understand what is where. And of course, at the end, give the users the possibility to set the settings which they would like, or at the end, just set it to your company standard. And in terms of the GA drawings, GA views, when you try to do it normally from the Tekla UI, you need to pick some 3D view from the model. And with the Grasshopper, you are getting some quite big superpower because you can set up this bounding box, this restriction box for your view according to your needs. And typically, at first, you need to think, okay, so what will be my final view plane? From what angle I want to see my structure? And then you should make some planar orientation of your initial geometry coming from the 3D toward your view plane. And as you can see here in the screenshot, this is the typical workflow that you are orienting your geometry according to the view plane. And here I'm just calculating the union box to see how big the X, Y, Z coordinates should be to encapsulate my bridge for that purpose. And things are much easier when you deal with the parts. So whenever you want to create the view on the cast unit, an assembly, or single part, then you don't have to think about those restriction boxes because Tekla will do it on itself. You just need to plan to pick the type of the view. Is it the front, top, back, bottom? And then Tekla will calculate those restriction boxes on your need. So you don't have to be worried about that. The last thing about the views is that if you are using Tekla version older than 2025, then probably you will notice some missing settings, some missing filters, and missing object level attributes. And unfortunately, there was the bug in the Tekla Open API before the 2025 release, so those settings were not applied when you created the view. And then you need to use this trick. You right click the view component in Grasshopper and pick the use macro. And then those settings will be loaded. But of course, it will increase the time of inserting those views. But thanks to Tekla Open API developers, from the Tekla 2025, it is fixed, so you don't need to use that hack. Now, let's go to the dimensions because those are quite a big one, and there's a lot what I can talk about the dimensions. But let's just be very let's treat it in a simple way. So, whenever you want to place the dimension, you need to answer at least three questions. The first one, what do you want to dimension? And I mean, what kind of a 3D object coming from the model you want to dimension? And typically, it comes from some filter. So as you can see, the component at the top right corner, the object match, is working like that you are provide the name of the filter and you are getting the objects which are correct, which are meeting the conditions inside of that filter. But of course, it depends to pre-create those filters in your environment. Maybe you are in such a rich company, rich in terms of the knowledge, that you have it already created in the environment. But there is also another approach when you create those filter logic inside of your Grasshopper. So as you can see at this big part of the screenshot, there is the grouping objects, and your model objects can be grouped by different kind of properties. Those can be custom properties, some reports, some UDAs, and then you can streamline different kind of grouping. Then you will just at the end achieve the objects which are needed. So then you will be able to answer the first question: what I want to dimension, what kind of objects I want to have. But then you need to answer the second question, and that is even more tricky because you need to find the dimension points. Which points should be picked from, hundreds, millions of different points available in the drawing area? So for that purpose, this is the most typical approach. When you are orienting the 3D geometry according to the view display coordination system, and then you still have the 3D representation of that element, but when you just cast the shadow, when you use this B-Rep projection border, which come from the drawing link, then you will be able to find edges visible from some particular angle. And of course, this is mainly about the solid geometries. Maybe you want to place the dimension about the start point, end point, maybe component points. All of that can be done with the combination of the live link and the drawing link. Just be aware that whenever you want to place the dimension, those points will be reflected in the display coordination system of the view itself, not in the 3D. So that is quite important to remember. And the last question, which you have to ask, even more tricky, is where that dimension line should be placed. Because, okay, now I know which points should be annotated, but where to place the dimension, to the left, to the right, to the top, to the bottom, where it should be. And as always, there are different approaches. You can always use the free attribute for the dimension line attributes, and it will let Tekla to place it whenever it feels that there is a place. But if you are looking into the drawing link, then you probably want to have more control over that aspect of the drawings. So this is one of the most easy ways that when you see your element from some side, like this, from the left side, I want to get those corners for the foundation, the top left and bottom left, then you are moving that edge in the negative direction. So here, with the help of that slider, which is now saying 2000, you can move the dimension line to the left or to the right. This is one of the approaches which you can use for this purpose. And now we answered three questions about the dimensions, so let's go to the next area, and those will be the level marks, something which I think is quite valuable because you can now place those however you would like. And the level marks insertion is quite easy because you just here need to answer two questions. What point should be annotated with the level mark and where that mark should be placed? That's all, the base point and the insertion point. But there is one tricky thing because whenever you work in a 3D area and you make the flattened projection in a 2D drawing, then very often the same objects will be visible toward the Z depth. So here you just have to trust me, but this little rectangle visible under the level mark, there are 5 different pies which should be annotated. And you don't want to place 5 level marks in the same place. So you need to incorporate some kind of a logic inside of your script to do it in a different way. This is just a sample when you are trying to group those objects by their bottom level. The next topic is about the view positioning, and just remember that there are two different ways to position your views. You can position those relatively, so you say that that view should be moved by some vector, or you can position them absolutely, so you say that the corner, one of those corners, one of those anchors of that view should be placed somewhere. What is the difference? The grasshopper components are recomputed every time when you change the left side. So for the relative one, if you will change the vector or some things on the left side, the view will move, 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 move. And you will not end in the final destination. So very often you will find yourself in a position that you want to use the absolute positioning, which can be done with the drawing link. Then sections. And with the sections, there are two different approaches. So you can place the normal, typical line section or the curved section. And the curved section are especially useful in terms of the bridges where you have some curvature. And as you can see, there is quite a lot of different inputs because you need to provide the line and also the depth, how much of your 3D space you will see forward and backward, but you will figure that out. Just be cautious with making some assumptions about the sections. So you can have one bridge and have the great idea where those sections should be automatically placed, but very often you will find yourself in a position where in some different project it won't be exactly in the same place. So maybe it will be better just to expose the exact placement of that section via the user interface to the end users, because maybe your script will not be able to figure it out every time. And then what I said about the batch operations, which I really like because I believe that on every project you need to deliver something at the end. The Tekla model is not enough. And maybe you're using the Beam Publisher. That's great. This is the great tool. But with the drawing link, you can also do some things like here presented. So the IFC, older one, and also the 4.1, PDF 3D WG. And what I want to highlight here is this very small script. So as you can see here, I am getting from the model everything what is according to the material steel filter, and then I am grouping those objects based on the assembly position. So I want to have smaller buckets which will collect only those things which are unique in terms of the assembly position, and then I'm creating for every assembly position, every steel assembly position in my model, separate IFC. Maybe you have such requirement in your project to create the IFC per element, but rather per floor, maybe per some area, per some building, and just making it manually by changing the filter, selecting and exporting is quite tiresome. So you can use the drawing link also for generating the IFCs. The next topic which I want to raise is the Grasshopper application, and it was already mentioned today, the Grasshopper component. Great work done by Sebastian. And this is all about this, that the scripts can at some point be messy. There will be a lot of things, maybe not so bad as this one, but still, non-Grasshopper users will be afraid about consuming stuff like that. So that's why Sebastian at some point developed the Grasshopper component, and I at some point developed the Grasshopper application. And of course, the question is why? Why I had to do it once more? Because the Grasshopper component, so the part of the live link, is the component. It is living in the model area. But the Grasshopper application is rather some kind of a macro. It can invoke, it can trigger stuff both on the model and the drawing part. And this is the way how you can expose your functionality to the end users. And that also can be downloaded from the Tekla warehouse. And as I am very close to the end time, I will just want to raise one more topic. If you see those presentation and you saw also the previous materials created by Sebastian, where it's super amazing, then you can think, okay, I want to learn Grasshopper. And the question is how? And as Sebastian said, those two different scripts, the model part and drawing part, are available on the GitHub. Here's the QR code, so you can grab those and try it on yourself. But as always, maybe you will get confused, maybe you will not know something. So then there's always a chance to use some other approach. And if you are living in a bridge world, then you know this guy, Chris Voiswav. He's famous, I believe, mainly from his involvement in the Randselva bridge, the first drawing class. And I really like Chris. And there is a course which you can join. This is the Grasshopper in Tekla. And there you will find a lot of different use cases, both for the model part, those are covered by the Chris, and also for the drawing part. So there you can find a lot of materials when I am going through all of those 152 components and also trying to present the use cases of those, because this is the essence of the drawing part. So whenever you want to try more, then just follow that QR code. And that's all from my side. I am a little over time, but I hope that there will be some questions and there will be the time to answer those. So let's see.
Thank you so much for the presentation. Yes, no, we have 3 more minutes to go. We have a question here. I will read it. I just gonna. For both Greg and Sebastian, is there any plan to include support for section views with variable curvature in either Tekla or in the drawing link?
Okay, so as far as I know, as Gabriel pointed at some point, there is the extension available in the Tekla warehouse for such task. And the extension, it works like that it splits those variable curvature into smaller pieces, into lines and normal arc curvatures. And then it tries to place those on the drawing. And at the end, you will end with multiple views, just a constellation of all of those. And I believe that without, heavy done at the Tekla engine itself, it won't be possible to add it into the drawing link.
Yeah, correct. That's the best thing we have right now. But I guess you could recreate something like that with Grasshopper as well yourself, just placing those views. That's probably a fun exercise.
Thank you for the answer. We will see. We have 1.5 more minutes, so if it's any more questions, please write them now. It seems like people are thinking about what they will have for will write questions after this event. So again, thank you for a good presentation and thank you for a very important subject.